Hello there, welcome back. Good to see you back on the channel again. So in this session, we'll be focusing on writing SQL queries using our MySQL database. So we'll be focusing on some DDL queries, DML queries, and the concepts on joins. We'll also learn the clauses like order by, group by, havings clause. So we'll start working on the queries. For this, I've already installed MySQL using XAMPP. In the previous lecture video, I told you how to install XAMPP and start the servers. You can very well see here, MySQL database is running on port number 3306 on my laptop. So you should start the servers, and then I'm going to use the command line interface for working with MySQL database. So you open command prompt and traverse to this directory. Right now I'm inside this folder, bin folder, which is present in MySQL, inside XAMPP folder that exists on the C drive. After this, you need to log into your MySQL database server using this command MySQL. The username -u is root. So I'm logging in as the root user and there's no password set. So I'm not giving any passwords here. So let's log in. Yes, I've logged in. And the very first thing is we can see the list of databases that are available. The command there is show databases. So this is the command, and you can see the list of databases that are available. And you can create your own database like this, create a database. And you can give the database name. I'm giving my name here. You can give any name you want. So create database Satish now creates the database. And again, you can view show databases. So now you can see the database is created. The next thing we can do is we can also drop a database. The command is drop database and database name. So when you're dropping a database, you have to be a little cautious because you'll be dropping all the tables that are part of this database. So when you just again look at show databases, so you can see we have dropped the database. But anyway, I'll again create this create database Satish, so that we'll use this database. Say show databases. So database has been created. Say I want to switch over to one of the databases. Say if I want to use this particular database, I can very well say use is the command and then the database name. Database name is Satish. So database changed. Now whatever tables we are going to create will be part of this database Satish. Let's start creating tables. Before creating tables, we'll take a brief look at an introduction to the data types available in MySQL. Say you have this int data type for storing integers. You can give the size of your integer in brackets like this. And int has got some variations like medium int, tiny int. So it depends on the kind of storage that these variables offer, and large int. So we'll be using int, and if you want to go with saving space, then you can go with tiny int. If you have a very large integer, then large int and medium int. So you can always refer to the sizes with respect to these data types. And we'll be frequently using int for all our declarations. And we also have float, and the float, you can give the size and then the number of decimal places. So you can declare float variables like this. And you can also have characters. This is a fixed length character. Say you can give character and then the size. You can also have text for your string data type. You can give the size of your text. Again, text has got some variations like tiny text, medium text, long text. It depends on the kind of info you want to store. So we'll be going with text in our declarations. You also have variable length characters, that is VAR. Say you want to store the names of persons, and you're not sure about say you just fix a maximum size of 10 characters. If the name of the person is just 3 characters, then only the space for saving 3 characters will be assigned. So these are variable length character assignments. Whereas when you go with character of 10, always 10 bytes will be assigned for the name field, irrespective of what the actual size of the name is. Whereas when you talk about variable length characters, the size will be taking up the actual size of the name that is being entered as an input. But we'll have some maximum size for the field like varchar of 10, wherein the maximum size that can be stored is 10 characters. So that's about the data types. We have the date data type. So you declare that as a date, and the format for date is you can enter the year, and then the month, and then the day. So this is the format, and whenever you're entering strings or dates, you give them in quotes. Integers, no need to give them in quotes. So with this small basic introduction on data types, let's start creating a table. So we'll create an employee table. Create table is the keyword, employee is the table name, and we'll have some employee ID. This is integer. I'll say it's int of 10, and employee name will have that to be a variable length character. So varchar of 10, and employees phone number we can say it's a character of 10, is fixed length, and salary can be int of 10, and we can have address can be variable length character of 20, and we can also have one more date field, say join date, for the employee to be of type date. That's it. So we are creating a table here. We have just used the data types we have learned earlier, and we have given the columns. Please keep in mind the syntax is create table is the keyword, employee is the table name, and you separate every field with a comma, and then you give the data type and size for all the fields. That's it. So when your query is okay, it means that the table has been created. So now the table has been created. How to view the definition for the table? You type DESC and then the table name. So you're going to get the table schema here. So you're going to have all the fields, the types, and whether null values are allowed or not, and what kind of constraints are being described on these columns. So that's how you create a table. And if you want to view all the tables inside a database, the command is show tables. So this gives you all the tables inside your database. The next thing we're going to learn is we'll learn some DDL commands like altering the tables. Say I want to drop a column, or else I want to add a column. I want to change the data type for a column. Such things we'll see now. Some basic DDL commands on the tables. So it's alter table. Let me drop this column address. So I want to drop a column for a table. How to perform that? We have to use alter table. Table name is employee. Drop is the keyword. Column is the keyword. Whatever column you wanted to drop, and that is address. So now we are dropping this column. Let's again take a look at this table employee. So you can see we have dropped this address column. Say if you want to add a column to an existing table, again we have to go with the alter table commands. The command is alter table. Table name is employee, add, and whatever column we want to add here, that is address, and the data type for the column, let's say it's varchar of 20. So the column is added. Let's see the table now, whether the column has been added to the table. The next thing we are going to take a look at is changing the data type for an column that's existing in the table. For instance, if I want to change the employee ID to character of 10, right now it's declared as int of 10. How to perform that? We'll go in for alter table commands, alter table employee, and we'll use modify. Whatever column we wanted to modify, that is employee ID, we'll give the new data type, that is character of 10. That's it. So we are modifying the data type for an existing column. Let's view the table now. So you are able to see here the employee ID, which was earlier integer of 10, is now modified as character of 10. So we have seen some important things like dropping a column, adding a column, and then changing the data type for a column. So when you're working with these things, you have to be cautious about the data in these columns. So if you're dropping a column, the data is dropped along with the column. So first you see to that your data is compatible to the data type you are modifying to. Say if I have all strings, I can modify that to integers by just running an alter table commands. So before running all these commands, you should be cautious about the kind of data that is present inside your columns. Now let's take a look at inserting a record into this table. Let's insert. So the syntax is insert into table name values, and we'll be inserting the employee ID, which is now a character. Let me say the employee ID is 121. Employee name, I'll give my name Satish, and employee phone number, some numbers we'll enter. It's a character. And salary, it's integer, so let's give some salary. And join date, we have to give that like this, 1992-01, month and the day. Some date we'll enter, and address, we'll say it's Vellore. close the parenthesis, semicolon. So whatever that is string, you please keep that in quotes, and even the date you have to give that in quotes. You follow this format YYYY MMDD, and you insert a record. Now how to view a record? You have to use the select command, select star from table name employee. So here is our record: employee ID, name, phone, salary, join date, and address. We have successfully inserted a record into our table. Now let's work on certain constraints. What are constraints? We have already learned certain constraints in other database management system courses. So we know primary key, default, check, and not null, unique. So all these are some of the constraints, and very important, we have foreign key. So what we'll do is we'll understand all these constraints. One thing we're going to focus on here is we'll see how to apply these constraints on an existing table. We'll use alter table commands and we'll enforce all these constraints. So we have our table here, employee. So we'll make employee ID to be a primary key, and we'll make name to be not null, phone number to be unique. We can have a check constraints on salary, like salary should be greater than 0. Next, we'll understand how to make the address to be by default valor. After understanding all these constraints, we look at creating another table, the department table, and linking the department table with the employee table using the foreign key constraint. So let's start with primary key. How to establish primary key for an existing table, and you have to establish employee ID to be the primary key in this employee table. So we'll use alter table commands here. It's alter table, table name is employee, add constraint is the keyword. We have to give some constraint name. The syntax is table name underscore column name underscore primary key PR. You can give any name here, but I followed this because when we get a violation, we'll know on which table, on which column, and what is the constraint that has been thrown. So that is the constraint name, and the keyword is primary space key. On which column we are going to establish this? On EID. So that's it. We have established the primary key. Let's take a look at our employee table now. So it's going to tell us what is the key is the primary key on employee ID column. Now let us make name to be not null. So how to make that? We'll go with alter table employee modify. We have to give the column name, and then what is the column data type, varchar of 10, and we'll say it's not space null. So we are making name to be not null. The user cannot enter any null values for the name field. Now let's describe the table. Let's see. Yes, you see, null is not allowed. No means it's not allowed, whereas the other fields, null values are allowed. So we have understood how to establish a column to be not null, how to establish a primary key on a column. Now let's take a look at applying unique key constraint on the phone number column. What is unique key? Every value that you enter inside that column should be unique, whereas null values are allowed. That's how it is different from a primary key. In primary key, every value should be unique and null values are not allowed. So let's establish phone numbers to be unique. What it means? The users can have phone numbers. When they have a phone number, it should be an unique value in that column. And there can be users without phone numbers too. So how to establish unique key constraint? We will use an alter table command. Alter table employee, add constraint is the keyword, and then the constraint name. So it's table name underscore column name, that is phone underscore UK, and the keyword here is unique. On which column? It's on the phone number column. So we have established a unique key constraint. Let's check the employee table. Yeah, you can see here unique key, phone number is an unique key. Now we'll go ahead. We will establish check constraint on the salary column, saying that salary should be greater than 0. We can't have salary to be 0. That's the meaning here. So let's have a check constraint. So it's alter table, table name employee, add constraint. What is the constraint name? It's employee table underscore column name is salary, and CK is the check constraint. And the keyword is check, open parenthesis, give the condition. Salary column should have values greater than 0. So we have established the check constraint on our salary column. Next, we'll see how to make the address column to have default value to be the address. So it's alter table employee. We'll say modify address default. We'll give value. It's alter table employee modify address, and then we should give the data type varchar of 20, and then we can say it's default value. I hope it works now. Yes, the error that was part of this query was we didn't give the data type here. So when we are using modify, we have to give the column name, data type, and then the constraint. So we have established all our constraints on our employee table except the foreign key constraint, for which we need another table. We'll try and insert records. We'll see whether we're getting any violations when we are inserting data against these constraints. So let me insert a simple record here. Insert into employee values. Let's go with employee ID. Was the employee ID we have inserted earlier? It's 121. Maybe I'll show you what happens if you insert the employee ID again to be 121. Let's insert 121 again. So we should have a primary key violation here. That's it. The other records, we'll insert something Matthew, and phone number to be some number, and salary to be say 6,000. Join date, some dates I'll insert here, and address, we can say it's Mumbai. We're just going to get a violation here. See, the violation is duplicate entry 121 for key primary, because we are trying to again insert 121. So we're getting a violation. Like that, we'll try and insert salary that is equal to 0. It's not greater than 0. So we'll not have a primary key violation. We'll try and insert salary that is 0. We are just checking whether the check constraint works. There's an issue somewhere. Okay, so it's like insert into employee. It's a 2-line statement. That's the issue. Let's again try and, yeah. Now it's 122 Matthew, and let's try and insert 0 for salary. You can very well see here constraint, table name, salary column, check constraint failed because we are trying to insert 0. So our check constraint is fine, primary key constraint is fine. Next we'll try and see our unique key constraint. So unique key, what is the value of the phone number we already add in our table? It's 878877. 878877. Let's try and insert that here. So it's salary can be 10. So we're not violating that. 87887. That's what I guess. 878877. I'm sorry. So it's 8877. Now we are trying to have a duplicate phone number. Immediately there's a violation. Duplicate entry. It means employee table phone number unique key constraint got violated because we are having duplicate value in that column. So our unique key check constraint primary key works fine. Let's just check our default. What happens when we don't enter this address to be anything? We'll just give null for the address. Let's check whether value is getting entered by default. So insert into employee. Maybe we'll enter only employee ID, and the next one is name, phone number, salary. We'll just enter these values. Open parenthesis, employee ID, we'll have it as 122. Employee name, we'll have it to be Matthew. And employee phone number, we'll have some phone number. Something like this. And salary to be some 3,000. So we are not entering the address here. Address by default should be Vellore. That's what we are checking here. Query is okay. Now let's perform select star from employee. Yeah, so our default constraint is also working. See, by default, the address has been entered as Vellore. If you're going to give some address, then that address will be taken up here. If you're not going to mention any address, then by default it will be valor. Join date we didn't give, so it's null. The other values got inserted. So we have effectively tested all our constraints. Let's go forward with the next constraint, that is the foreign key constraint. How do you establish foreign keys between two tables in our MySQL database? So for this, I'm going to create another table, create table department, and department is going to have two fields, department ID, which will be of some int of 10, and department name, which will be character of 10. So this is the department table, and very important thing, we are going to make this department ID to be the foreign key in our employee table. The idea here is we should know the department for which an employee works. Say Satish works for the computer science engineering department, and using the department ID, I'll be able to know the department name for that employee. So the concept here is having a separate table on department ID and department name, and mapping each employee to which department he belongs to. So we are going to make this department ID a foreign key in the employee table. For this, the very first condition is you should make department ID to be the primary key in the department table. Only when this is a primary key here, it can be a foreign key in the employee table. So how to establish a primary key? We can give alter table department, add constraint. Now we are going to establish department ID to be the primary key. So it is add constraint. The table name is department. Column name is DID, primary key, PR. And the keyword is primary space key, on which column DID. Very important. This is the first thing. You have to find a primary key on this parent table. So department is the parent table, because this key will be made the foreign key in your employee table. So we have made we have identified the primary key in the parent table. Now let us add a column, the department ID column in the employee table. So we'll use alter table commands here, alter table employee, add, say I'll add department ID. And another important thing is the data type for department ID should exactly match the data type that's present for the department ID in the parent table. So we give int of 10, and that's it. So we have added this describe employee. So we have added another column, which is department ID, which is actually a foreign key, and it will be referring to the department ID in the department table. Now what we'll do is we'll select star from employee. What will be the values in the department ID column? It's going to be null. Maybe we will insert some department IDs here. For Satish, let me insert a department ID. Before inserting a department ID here, let me insert a record inside the department table. What is present inside the department table? Select star from department. So we don't have any department records here. Let's insert a department record in the department table. Insert into department values. Let me enter the department ID to be 424, and the name is scope. So we have inserted a record. So what we have inside our department table, we have this. We have 424 and scope. Now we should say that this specific department is the department of Professor Satish. So we should have 424 updated as the department ID here. For this, we'll use an update command. It's update, table name is employee, set. What we are going to set department ID to be 424, where employee ID is 121. Now let's do select star from employee. You'll be able to see the department ID for Professor Satish is 424. What is the department name for Professor Satish? It is select star from department. So you're going to have 424 here. So you'll be able to link these two tables, right? The department name for Satish is scope. How did you perform that link? Department ID, we are taking that from the foreign key column. We are mapping that here, and we are finding the department name. Very simple thing. We've already learned this earlier in our DBMS courses. Just a refresher now. Now, the thing is, why we need this foreign key constraint? What happens if you don't have a foreign key constraint? See, what can happen is I can update a department number for Matthew, which is not even present in the department table. I'll just show you. Say I'll just update department ID to be 425, where employee ID is 122. So now it's very well happening, right? Now when you perform select star from employee, you'll be able to see Matthew belongs to department number 425. What is the department name for Matthew? Is that present in the department table? There is no such department as 425. So we are losing a data integrity here. We can have something that is invalid. Matthew belongs to a department, but that department doesn't exist inside our university. So this is the issue. So to prevent such issues, we establish this constraint. Whatever you're inserting here should be present in your base parent table. In your parent table. So whenever you're trying to insert anything here, it will first check whether it is present as a primary key in the parent table. If not, it will throw you a violation saying parent key is not found. So this kind of an issue can be avoided when you establish foreign key relationships. Let me now update the department ID for Matthew to be null. So how will you update that? So it's update employee, set department ID to be null, where employee ID is equal to 122. Select star from employee. Say this step is very important before you establish a foreign key constraint. If you have 425 here, which is not a valid data, and you try to establish a foreign key constraint, you'll not be able to establish because there's a violation with respect to the data that is present and the constraint you're trying to apply. So please fix your data first if you're trying to apply a foreign key constraint on a table with data in it. Very important. So I'm just fixing the data. So we have only valid data here. And now I'll go in for establishing the foreign key constraint. The command is alter table. Table name is employee. Add constraint is the keyword. What is the constraint name we're going to give here? It is the employee table. Underscore column name is department ID underscore foreign key. And the keyword is foreign space key. What is the column in the employee table? That is department ID column in the employee table. References which table? Department table. Department tables. Which column? Department ID. So this is the syntax: alter table, table name, add constraint, constraint name, foreign space key, the column in the current table, references which table and which column. So we have established the foreign key constraint. Now, what is the use of this constraint? Say if I try and update department ID to be 425, which is an invalid value. There is no department ID called 425 in the department table. So if you try and perform this, you'll get a foreign key violation. See how clear it says, cannot add or update a child row. A foreign key constraint fails. What is the constraint? Employee underscore department ID underscore foreign key. So this is the constraint: department ID references department tables department ID. So it's just trying to insert 425, but 425 is not present in your department table, so a foreign key violation comes. So what is the use of this? We are not going to allow data integrity issues inside our design. So I hope you are clear with all the constraints now. We have seen a good number of constraints: primary key, foreign key, check constraint, unique constraint, not null constraint, and default constraint with good examples. Now let us take a look at the concept of joins. Some joins we'll see joins like equi join, left join, right join. We'll take a look at, and then we'll look at the clauses group by, order by, and having. So let's take a look at joins. So what are joins? Say we have select star from employee. We have this table, select star from department. We have this table. Now the concept here is I want to print the employee ID, employee name, and department name for all the employees. That's the concept. Let me also insert one more record inside the department table. Say insert into department values. Let's insert one more record. Say we call that to be 425, and the department name is site department. So we have a few records in our department table too, and a few records in our employee table. Now we need to print the employee ID name and the department name for every employee. For this, we'll go with an equi join. That is, this department ID should be equal to this department ID. Then it will bring out the employee ID name and the department name. Simple equi join. So we'll write the query. It is select what we are going to select: employee ID name, department name from employee table, comma department table. The condition is where department underscore ID is equal to department ID. So here this is the department ID column in the employee table and department ID in the department table. That's it. So we are able to see employee ID to be 121 Satish and department name is scope. So when we use join, you have many tables and you want to join them and say you want to bring the contents from many tables and produce a report to the user. So we have performed a very simple equi join here. Let's take an example for left outer join. So what is a left outer join? Say I want to find all the employees and their department names. Say if an employee has a department name, print it. If an employee like Matthew who is not having a department name, then just print the data for this employee. So bring all the matching and non-matching records from the left table and only the matching records from the right table. Here the left table is employee, right table is department. Let's take a look at the query. It is select employee ID name department name from employee. The syntax is left join department table on what is the keyword, what is the join condition here? Department underscore ID is equal to department ID. So it's fetching all the matching and non-matching records from the left table and only the matching records from the right table. So this employee has got a department name, whereas this employee is not having a department name, but then his values are fetched because that is the concept of left outer join. Let's take a look at right outer join. What is right outer join? It's going to bring me all the department IDs and department names that are not having a matching record with the left table, whereas it will bring only the matching records from the left table. Let's run this demo. You will understand this. It's something that we have already learned. It's select employee ID, name, department name from employee, and the syntax change here is right join. Instead of left join, we are giving right join table name department on what is the join condition, that is department ID in the employee table should be equal to department ID in the department table. So what's happening here is it's fetching all the matching and non-matching department names from the right table, department table. So we have scope and site here, whereas it's fetching only the matching records from the left table, the employee table. So only Satish has got a matching department name. The other employees don't have, so we are having null in EID and name. So that is a right outer join. So I hope you're now clear with the concepts on left outer join, right outer join, equi join. You also have a cross join. Say what is cross join? Select star from employee, cross join department. So you're going to have every, okay, there's a spelling mistake with the department. Yeah, so you're going to have every record in the left table being matched with every record on the right table. So that's the output of the cross join. Now let's move on further. Before winding up, let's take a look at these clauses: group by, order by, and having. And with that, we'll wind up this small introduction to SQL queries using MySQL database. So let's first take a look at our table. Select star from employee. Maybe we'll insert more records here. Maybe another 2 employees. Let me insert into employee values. And now let me insert an employee with ID 123 and employee name is Tom. And employee phone number, let's enter some phone numbers here. Employee salary, let's say 50,000. Joining date, let's say it's 2020 01 24. Address, the address is Mumbai. and department ID is 425. Again, it's a spelling mistake. I'm sorry for this. It's employee. And let's go with the data. Yeah. Let's insert one more record for Mumbai. So it's insert into employee. And we'll go with 124 Chris. Some phone numbers here. Salary can be 10,000. Joining date 2021. He's also from Mumbai. His department is scope. So we have all these records in our table. Now we'll understand group by, order by, and havings clause. And before going into that, let's take a look at some of the aggregate functions available. That is select sum of salary from employee. So it just aggregates the salary column, prints the total salary. If you want to find average salary, select average of salary from employee. So average is again another aggregate function. You also have min and max. Select min salary. What is the minimum salary from employee? Like that, you have max to max. You also have a count, returns the number of values. Select count of salary from employee. So you have four entries here. That's the use of count. So these are some aggregate functions that are available. We'll be using that with group by and order by classes. We can also use the between operator here to get employees that get a salary within a range. For instance, select employee ID name from employee table, where salary, we'll use this between, and then we'll give the range, say between 1000 and 10,000. Who are the employees who are getting this salary? We'll just see their names and employee IDs. So we have Satish, Matthew, and Chris getting a salary between 7,000, between 1,000 and 10,000. So when you're using between, the boundary conditions are also included. Chris gets a salary of 10,000. See, his entry is present. Okay, now let's move on to group by. So what is the use of group by? Say I want to group employees by address. Total salary of employees from Vellore and total salaries of employees from Mumbai. So group employees based on the address. So group employees based on their address and then print the sum of salary. Let's perform this query. It's select sum of salary, and we'll also get the address out for the employees. Say for this address, this is the total sum. We cannot retrieve employee name or employee ID, anything like that. You'll get not a group by expression error. So please see to that when you're grouping by a certain field, you can take that field out and then you can use the aggregate function. So it will give you Vellore, what is the total salary, Mumbai, what is the total salary. So select address sum of salary from employee table. The clause is group space by. Which column you're going to group by? Address. So Mumbai it is 60,000, Vellore it is 10,000. Let's check. Say Vellore, we have two employees, total salary is 10,000. Mumbai, two employees, 60,000. So we were able to achieve grouping by a specific column name and finding an aggregate of the values. Next, let's see what is the use of having clause. Having clause can be used for filtering the groups. Say I want to see only groups wherein the value, the total sum of salary is greater than 10,000. I can filter groups. So it is select address sum of salary from employee. Group by, we are grouping by address. And now we are filtering it. Having sum of salary to be greater than 10,000. So only those groups wherein the total salary is greater than 10,000 will be shown to us. So now we are filtering groups. So whenever you're using this having clause, it's used for filtering the groups that you achieve by using group by. Okay. Finally, we also have this order by. So order by is used for ordering the column values in either an ascending or descending order. Say for instance, if I want to order the groups in ascending order, so I can go with order by. So it is select address and sum of salary from employee group by. We are going to group it by address, and then we'll go with order by, on which criteria we're going to add order sum of salary. So it'll order it in the ascending order by default. So you see, it's ordering it in the ascending order. Sometimes you want to force the descending order, then what you can do is you can give order by sum of salary DESC. So that's going to enforce the descending order. I hope you were able to follow this simple introduction to MySQL database. So what we have seen is we were able to perform a lot of DDL, DML queries. We understood the concepts of joins. We understood the use of the clauses group by, having, and order by. So with that, we will come to an end of this small introduction. I hope you were able to follow all the concepts. If you have any questions or queries, you can leave your comments below, and we'll be winding up this session now. Thank you all for listening. Take care.